just looking at some photos, and these are from high altitude weather balloons, and also there's some from flights, so they're taken from airplanes. And I just had some questions. So basically, so if the sun's here, right? How? So if it's low like this, then if it rises in the east and sets in the west, that means that the Earth would have had to have turned, and basically it would have to be way behind the globe. So it would have to almost be sunset at this point. But the sun's shining off of the top of the clouds. So, I mean, that doesn't make sense. So, what I'm thinking is, if you really want to prove once and for all, if you wanted the absolute proof, what you could do is you have to find weather balloon footage. And if anyone can help me with this, because I've been looking, I found some weather balloon footage at like 9 in the morning. I found some at like 4 o'clock p.m. But I want it to be exact, around noontime. So it has to be right at noontime, because at noontime, that's when the Earth is supposedly facing the sun, directly lined up with it, perpendicular to the sun. So if the Earth is perpendicular to the sun, that means if you go up in a weather balloon, if you're in a high altitude, craft, like a plane or even a hot air balloon or whatever, the sun would be directly above you. It wouldn't drop down towards the horizon like this. My hypothesis is that even at noontime, it would still drop down to the horizon like this. It would be right above the horizon. It definitely wouldn't be 93 million miles high, because then you'd have to look straight up to see it. It wouldn't be here, because remember, if it's in the tropics, right? If this is in the tropics, and this is clearly during the day, and this is in the tropics, I'm literally looking south, and I can see that the sun's right above the Earth. And the land obviously goes further out, but you can't see that far. So this land goes way, way back. And the sun is not directly over right here. That's just a reflection, okay? So the sun is back here over the tropics. And the tropics are way back there, because there's so much, it's so big, it's humongous. You gotta remember that. It's flat. The whole thing is all one big landmass. It's humongous. It's bigger than what they claim the globe is. They say the globe is big. The flat Earth is bigger, okay? That's why you can't get a photo of the whole flat Earth, because you can't see anything. You can't go high up and take a picture of the continents. You can't see anything. There's clouds in the way. There's atmosphere in the way. Everything gets blurry once you get high up. So I'm just going to go through a couple pictures, and I'm just going to, just mention a couple things. But that's basically what I'm saying, is this is above the tropics. So I'm saying we're looking south, and it's above the tropics. And this is actually higher, but as everything further away, the ground goes up, the sky comes down. So this is actually higher, but it appears lower due to perspective. You know what I mean? But it's not 93 million miles high, because then you'd never be able to have this picture with the horizon and the sun in the same picture if that was 93 million miles high. This is during the day. This is daytime. And here's a picture from an airplane. So the airplane is probably traveling east or west, and you'd have to look south to see the sun if you're in the north, which is inside the Tropic of Cancer, on the flat Earth, but on the globe model, it's north. They call it north. And so you'd have to look south, and you can see that it's above the tropics back here. It's not 93 million miles high, and you always are going to see this. Every time when you go high up, the sun is always off to the side. It's never directly above you, 93 million miles high, even during the day, which makes no sense. This is from on top of the clouds, and it's like, how could you get a picture of Earth when there's clouds everywhere? There's so many clouds. And the thing is that when you see pictures like this, one thing that I always like to do is I like to turn them upside down, because when you turn them upside down, you can see that the sky now looks like the ground, and the ground, which is clouds here in this picture, will look like the sky. So, because the horizon is flat. And actually I have a picture of, there's water on the ground. It's a mirror of the sky, but it doesn't look like a curved mirror, and it would look curved. It's not like the curve would be noticeable if you're making a mirror with water on the ground. Let me get the picture. These pictures. So these pictures, this is a perfect mirror. If you turn this upside down, this will look like the sky, this will look like the ground, because it's a perfect mirror. Because of perspective, the sky goes down, the ground goes up. And then if you turn it upside down, it's the same exact thing. So if the Earth was curved, there would be a curve here. The sky would curve. But when you turn it upside down, it would be curving. It would curve the opposite way, but it's not curving at all, which is why it's still a perfect mirror, and it looks the same whether you turn it upside down or not. Another picture of the sun over the tropics. The sun's over the tropics. It's not that high up. It's obviously higher than this, but because of perspective, the sun's up here, but it appears down here due to perspective. Perspective lowers everything that's further away, and everything that's closer looks higher. That's why this plane looks like it's higher than the sun, but the plane's not higher than the sun. The sun is just further back than the plane. But if you think of everything converges to the center, so this sun could be up here, but appear down here due to perspective, but it's really high up here. You know what I mean? Everything to the right of your vision goes left. Everything to the left of your vision goes right. Everything below your eyesight goes up. Everything above your eyesight goes down. It all converges to the center of the observer's picture, their view. And here's another photo. If we're on a ball Earth, how does this reflection get here? It would have had to make it all the way around over 3,000 miles of land, because if this sun is about to set, that means that the Earth has curved back. So how does this sunspot get here when the sun is 93 million miles that way? If the sun's 93 million miles that way, then how does this get here around the curve? No, it'd be impossible, because the curve would be in the way. And so what that tells you is that's not what's happening. So this is really just looking south. That's looking south into the tropics, and the sun is right there. And because you're not in the tropics, you're probably, somewhere in America, or maybe you're in Europe, and you're not in the tropics. So you're hundreds or thousands of miles away from the tropics. And so the sun is going to be lower in the sky because it's so far away from you, because of perspective. And I'm almost at my limit, so I just want to end with this. Due to perspective, if the sun's up here, the sun could appear down here. It could converge into the clouds, but it doesn't mean it's in the clouds. It's above the clouds, but it converges into the clouds, and the clouds end up blocking it. because of